What is going on, guys? Welcome back. It's time again for a casual Codewars session where I'm going to try to solve programming challenges without editing out any mistakes or any thought processes that I have, so let us get right into it. Alright, now for those of you who don't know what Codewars is, it's a platform where you can do programming challenges. You have the different difficulty levels here, 8Q being the easiest one and 1Q being the hardest one. And the idea of this format, the purpose of this format is to show you my thought process so that you can see how someone else solves these problems, if I succeed, of course. And I also want to include the mistakes, the wrong approaches, if there are any, because I think it's important, especially for beginner programmers, to see that programming is not always straightforward. It's a lot of trial and error. It's a lot of Googling certain aspects of libraries or of functions or of algorithms. Now, of course, not Googling the solution. This would be too easy, but Googling certain aspects, looking up the documentation of Python or something like this. And also, the purpose of this is entertainment. So if you just want to watch and watch me solve the problem, the idea is I don't edit out any mistakes. I show you the wrong approaches. I show you when I fail. I show you when I have to Google. The only rule is I'm not allowed to Google the solution. I'm not allowed to use ChatGPT or anything. I'm only allowed to use stuff like documentation or Stack Overflow for basic things like how to sort a list in a certain way or how to flatten a list if I need that. So little pieces of code are allowed to be copy-pasted or at least to be looked up, but in general I have to solve the problem myself. I don't edit out anything, but what I want to try for this video today is I want to edit out at least the silent sections of just thinking, because sometimes to solve a problem I need to just shut up for 5 minutes and look at it and think about it. And if I always have to comment about what I'm thinking exactly every second, this will of course inhibit my problem solving ability. So I'm going to try to cut a little bit more, to edit out a little bit more this time, but not because I make mistakes, but because I just want to edit out the boring sections where I don't do anything. Alright, so the difficulty level I usually go for in these videos is 6 and 5. So I'm going to start with 6 as a warm-up here. And we're going to try to solve something that we haven't seen before, obviously. So let's look at this one. Difference of 2. The objective is to return all pairs of integers from a given array of integers that have a difference of 2. The result array should be sorted in ascending order of values. Assume there are no duplicate integers in the array. The order of the integers in the input array should not matter. So, okay, so we get 1 and 3 because they have a difference of 2, 2 and 4. And if we have 1, 3, 3, 5, 4, 6, okay. I think this should be quite easy, so let's go ahead and solve this in Python. 2 difference. So we get a list and we get a list of numbers. So if I go and open up or actually let's do that at the desktop. Let's say experiment.py. Okay, I actually have this file already. Or let's go and edit anyway. So the idea is I get some input of numbers. The order can be whatever. So something like this. I mean, we have no duplicates, so something like this maybe. And the goal is to get all the pairs of numbers that have a difference of 2. So actually, I think, now my first thought here is if I go from smallest to highest, shouldn't I get all the numbers by just checking if the next number has a difference of 2? So I would just go and say sort the list. Then I would get a list like this. And then all I have to do is I have to iterate. I have to start with 1 and I have to ask, looking at the next number, so looking at 2, is there a difference that is 2? No. Okay, so I go to 2. Is the difference between 2 and 5 2? No. Go to 5. Is the difference between 5 and 7 2? Yes, so save it. 5, 7. Is the difference between 7 and 8 2? No. Is the difference between 8 and 10 2? Yes. Save it, and then 10 and 14, no. I think that is straightforward, and it should probably work. So what I'm going to do now is I'm going to increase this here, and we're going to just say 4. I think we need to do that with the index, because if I do a for each loop, we're not going to get the next element. So I'm going to say for I in range length list. And then I'm going to say result is an empty list. And then I'm going to say for I in range length list, if list I if list I plus 1 minus list I is equal to, if that is equal to 2 exactly, then I'm going to say result append list I, actually as a list I and list I plus 1. And that's actually it, right? So I just have to return in the end result. The only thing is I think I have to go -1 here. I'm not sure about that, but I think so. So let's see if that works for the test. No. Okay, so, okay, because we need to have a tuple, not a list, but also because I get an empty list. For what exactly? Oh. Empty should equal 1, 3. So why do I not get that? Oh, okay. Got it. Because I didn't think about the following thing. If I have a 3 here, of course, I have to also check for 1 and 3. Okay, so you can already see I missed something. Okay, so how can we do that? Basically, we have to go... Now, I don't know if that's the most efficient solution, but you have to just look at a number and see... I mean, what's less efficient? If I go for each number and I go until I find a number, or how would I do that? Maybe I could do something like let's do it like this. For I in range length list, for j in range starting at I plus 1 until length list, I guess. And we can just say if if list j minus list I equals 2, result append list I list j, elif list j minus list I. Oh, I also forgot something else, because the problem is I didn't sort the list. I need to sort the list first. Otherwise, it doesn't make sense. So if that is larger than 2, then of course we can break out of this loop. And I need to sort the list. So I need to say lst is equal to sorted lst. Now, this is not the most efficient way to do this, but I think it should work unless I forgot something. Okay, it works, but I'm not sure if that is the optimal solution. Probably not, because this, if we think about it in terms of algorithmic complexity, sorting is done in, I think, O of n log n. Yeah. So n log n, and then you have, I mean, what is this? Isn't this pseudo-linear? I'm not sure what is pseudo-linear. I think that was pseudo-linear. But yeah, this takes some time, and then this iterates over the whole list. So we have O of n, it's already linear. Or actually it's pseudo-linear and then linear. And in here we have, I mean, what's the worst case? You have to go all the way until the end. Is that actually true? Because you can go max of 2 steps, right? If you go more than 2 steps, this should be O of 2, right? Or am I stupid right now? Because you shouldn't be able to go beyond 2 steps. I mean, it's not super complex, right? It's not extremely inefficient. But I'm thinking, is there a more efficient way to do that? I mean, another way to do that, I'm just going to do it down here as a comment, is to say, for each element, in list, check if this element plus 2 in list. And if yes, then add it. But then this checking operation is again, I mean, that would be quadratic, wouldn't it? Because I'm looking up, I think that would be quadratic runtime complexity. I think that's not as inefficient, so we're just going to submit that. So attempt, and there you go. Let's see what the other solutions are. Okay, this is interesting. We have a set of A. And then what does he do here? I mean, he does the... Okay, it's small in terms of code. I'm not sure if that's not quadratic, because 4x in A iterates over the whole set, meaning you have a linear runtime complexity, and for each of these he does an in, which again has to iterate over the set to check if it's in. So I think that is concise code, but I'm not sure if that's not less efficient than my solution. I'm not sure about that. Yeah, everything that has a membership and a for is probably... I'm not sure if I'm talking nonsense right now, but I would assume it's quadratic. This is also quadratic. You iterate over the array 2 times. This is... I don't think that's as efficient. Yeah, so I think the solution is quite good. Let's go for another one. Let's go for, again, a 6Q one. I'm just going to open a couple of them. Now, the important thing is that they shouldn't be too... Can I maybe sort them by not newest, but by... Or actually, let's go for newest. I don't want to do anything that's too comprehensive in the description, because I don't want to spend too much time reading the description here in the video. Allocating hotel rooms. This seems okay. Allocate customers to hotel rooms based on their arrival and departure days. Each customer wants their own room, so 2 customers can stay in the same room only if the departure day of the first customer is earlier than the arrival day of the second customer. Okay, the number of rooms used should be minimized. A list or array of n customers. Is the input. Each customer is represented by a tuple, arrival date, departure day. Okay. I mean, this is basically a scheduling, somewhat of a scheduling problem. Clearly customers 1 and 2 cannot get it. Okay, but the room doesn't matter, so... Or do they have any... Okay, so they don't have a preference for a specific room. They just have to be in separate rooms. I think we can do that. Let's see. Let's use my local editor again. So the idea is we have a list of tuples, and the tuples represent, arriving day 1, leaving day 5. Arriving day 3, leaving day 6. Arriving day 1, leaving day 2. Arriving day 5, leaving day 7. And then maybe, yeah, what do we have? Maybe staying just 1 day, whatever. Now the important thing is to just separate them so that they don't overlap. So I would say that we want to have, can we do it like this? We start by saying, let's do something like while list not, or while not list empty. So, or maybe we can say while length of list is larger than 0, we're going to do the following. We're going to say that room is going to be 1. The first room is going to be 1. And then we're going to say, okay, we're going to add the first customer to room 1. So let's say we have our solution. It's going to be an empty list. And we're going to say, okay, first customer. So for customer in list, we're going to say add the customer, or how do we do that? How do we model that? Now for the first one, I want to assign obviously just the room number 1. So that's not too difficult. The question is, how do I decide? Let's say I have a 1 already in here. And let's say I have, I mean, I cannot just delete it, right? Because then I have nothing. Let's do it in a different way. Let's say I have a dictionary, solution dictionary, where I have the room numbers as keys and the list of, so let's say 1, the list of customers as values here. So let's say I already removed that. So I say, if the list is empty, just add him to the list. If the list is not empty, so for example for 3 and 6, what do I have to do? I have to say if solution dictionary room, if the length of this is 0, we just say solution dictionary room, or actually we don't even have, no, we're going to do it another way. We're going to say if room in solution dictionary dot keys, we're going to do something else. We're going to say solution dictionary room is going to be equal to it's going to be equal to the customer in the list. All right. And if there already is a customer, like right now, what I have to do is I have to say, I mean, this is now not very efficient, but let's do it. Let's say for, now I cannot use customer again, for C in, and then solution dictionary room. We need to see if they overlap. So we need to say if, and now my arrival date has to be after their departure date, or can it be on the same day? Okay, no, earlier, so it has to be a difference. And also my okay, so basically I have to check if the C, if C1, or let's say, if customer arrival day 0 comes before C departure day, or if C arrival day comes before customer departure day, then I have to increase room by 1. So let me just make this a little bit larger here. And I want to break the loop. I want to break this loop here. So I'm here again. Does this make sense? No, actually, if I break out of this loop, I'm in this one again. So I go to the next customer, but I'm not done with this one, so I don't want to go to the next customer. I don't think that's correct. We need to restart the loop, actually. So basically we need to repeat the process until I have gone through all the rooms. How do I do that? I start with 1. Then I say I have a new customer. Then I say, I think that's the problem. I think if room and solution keys should be inside another loop. So we can say done equals false while not done. Now these are a lot of nested loops. Probably we have to do some optimization here. But basically the idea is to say here we have done equals true. And here now we say, okay, if, yeah, we need to break here. Otherwise, we can say solution dict room append customer. And we can say done equals true. I think this should work. Because now what we're doing is, yeah, I mean, this should work, I guess. It's probably not very efficient. But what we need to do in the end, of course, is we are done. And we need to say solution. Oh, now we have another problem, but this is not really a solution problem. It's more like how do we translate this now into the proper output format, because the output format is just the order and we don't keep track of it. So now a brute force way to do that is to just add to each of them an index like this, 1 and then and so on. We can do that just to see if it works. So we would have to say something like for element in list. Now let's call this list actually. For element in list, we need to say, or actually for I element in enumerate list, we want to say, no, this is kind of stupid. I mean, no, we don't have to do anything. We can just do it like this. We can say solution is equal to an empty list, and then we just have to say solution append room. I think this should work. Or am I mistaken? I think this should work. So let's just copy and paste this into here. Now we need to indent this. We need to say that list is actually, it's an empty dictionary. And here we don't have list, we have customers. And I think I don't use list. Oh, I do. Customers. There you go. And in the end, I just want to return solution. So basically, I have return solution. 1, 2, 3, 4, right? Yeah. Shouldn't this work? Let's try. I mean, maybe it's very inefficient. That could be a problem with a timeout. That could be a real problem, though. So maybe it works, but it works in a very inefficient way. Yeah, timeout. Okay, we cannot do it as inefficiently. Let's see. Now, obviously, this is, I mean, we have 1, 2, 3, 4 loops nested. This is definitely too complex. Now, let's just see if this actually works, at least locally here. List equals 1, 5, let's just print in the end solution. Let's print solution dictionary. Oh boy, this is already very slow for just 4 instances. Or maybe the problem is not, maybe actually it's not about the inefficiency, maybe it's not even terminating. Ah, I know why, because we're not removing the elements from the list. So maybe it's not that inefficient. Maybe it's about popping list.remove list.remove the customer. That would be it, right? Wouldn't that be the solution? Yeah, I think, I mean, does this make sense? Yeah, actually none of them can be in the same room, right? Let me just change this a little bit. Let's change this to 6 and 8. Okay, but actually this should work, right? So 6 and 8 should fit into 1 and 5. Why doesn't it? Why does it choose to add it to a new room? So the room... Oh, I'm probably not resetting the room number, right? Yeah, if I'm... Yeah, okay. That's also an issue. Still a problem. What's the problem? Okay, so we get the customer. We try to fit him into a new room. Now we start at room 1 and we try to see if 6, 8 can fit into room 1. So room 1 is in the solution. We try to see, let's say C is our 6, 8 and customer is our 1, 5. Now customer 0 is 1. That is less than, oh, this is not what I'm checking for. What I want to be checking for, I want to actually do the opposite. Or am I wrong? Am I stupid? Customer 1 is before customer... No, wait. I need to do it like this. No, still a problem. I'm brute forcing this right now. Let me think about this again. So 1, 5 and 6, 8. If 1, now when would they be incompatible? Either if 6 is actually smaller than 5. That would be incompatible. If C0 is greater than this. So actually customer 1 is 5 and it's greater than this. No, it's not. But this is greater than this. Okay, that's actually not the correct check because okay, so we need to say if this is the case, and so this can actually be greater than this as long as this is also greater than this. So customer 0 is smaller than C1, or this thing. Does this make any sense? What do you mean X is not in list? How can it not be in the list? If anyone at the second position is larger than the other one at the first position, and at their first position they're smaller. Is this actually what I'm checking for? I mean, what I'm actually trying to do is I'm trying to say they shouldn't overlap. So the last one let's maybe put this a different way. Customer 1 has to come before customer 0, or customer customer 1 has to come before C0, or C0 has to come, or C1 has to come before customer 0. And if that's not the case, then we have a problem. Is that correct? There you go. Now we have it. Now we have it. Or do we? No, this doesn't work. No, this doesn't work because 3 and 6. Let me just think. So why does he think that this is an okay solution? Let me just copy this and put it as a comment here. So this is obviously okay. Now I have a list 1, 2, 4, 4. To this now I consider adding 3, 6. Or it's probably done the other way around. So I probably have 3, 6, and 1, 2, and I'm considering adding 4, 4. What does the check do? It says, oh, okay, got it. We need to do it at the end of the loop because we need to go through all the elements. What did I do here? I think I'm making this more complicated than it has to be. Okay. For customer in solution dictionary room, I'm trying to see if that customer has a problem if there's a problem with any customer in that room, I need to increase the room number. And I have to break out of the loop. And then I want to restart, actually. I think the order is messed up. I have a room. If I don't have the room at all, I create a new one. If I do have a customer that conflicts, so let's use the example again. I have 1, 2. So I say 4 doesn't conflict with 1, 2. Because of that, I do not get into this, and I go to the next one. I go to 3, 6. Okay, when I go to 3, 6, I see that there is a conflict. So I increase the room number by 1 and break out of the loop. But when I break out of the loop, I do this. This is not intelligent. I shouldn't do that. Oh, I think this is one of these magical moments where we need to use a for else. I think this could work. Boom. That's one of the magical moments where we can actually use for else. Because the idea of for else, for those of you who don't know, is you only get into this branch if you don't break out of the loop. Yeah, this makes sense. Okay, let's go. So let's copy this and try to put it here. Let's try to indent this. Let's replace LST with customers. And this should not be probably, it should be a dictionary. Otherwise, I think it's a set, I'm not sure. And in the end, we want to, come on, 1, 2, 3, 4, return solution. Okay, I don't think this will work, but let's see. Number of rooms exceeds number of customers. How is this possible? What's the input I get here? I already get this for the first result. How can that be? Oh, actually, now I copied the wrong thing. 1, 2, 2, 4, 4, 4. 1, 2, 2, 2, 4, 4. No, 2, 4, sorry. It's not true. I get 1, 1, 2. But 1, 1, 2 is not correct, right? Actually, my solution is correct, but the order is messed up. Because that should actually be, considering, I mean, it should be 1, 2, 1, which I think is valid. 1, 2, 1. Okay, so I'm probably experiencing a problem with the order here. Where do I add to the solution? I add to the solution. Well, actually, shouldn't that be? I mean, does it even represent my solution? No, not really. I mean, let's just print what's happening when I say append solution. Print appending customer and then room. Let's do that here as well. Okay, so why is this appended? Why is this appended before I do anything with the other one? So why is this one appended before this one? For customer in list. Okay, why is this one handled first? I don't get it. Let me just see. Can I delete this? There you go. Why is my customer... I mean, what is... That's the list, and he goes to this one. How and why? Is this some... Am I stupid right now, or is this some Python behavior that I don't understand? This is my list. And I then tell him 4 elements in this list. And he picks this one. Why? Here I get the list in the correct order. Why is this happening? Interesting. For customer in list. And he handles the second one first. I don't understand. Let's see. For each Python wrong order. Okay, this is something else. This is not what I'm looking for. I think it's probably some obvious mistake that I'm not seeing right now. For customer in list. List is a certain list. Now let me just comment this out so we have less stuff to worry about. I'm just interested in the list and why the customer is picked in a different order. I have this list. This looks different now. I have the list for customer in list. I start with 1, 2. So I print 1, 2. Done equals false. While not done, we don't have anything yet, so I go here and I say room 1 is customer. Okay. And I append to the solution room 1 for the first element. Then I remove this customer from the list, which is probably why I jump to the next one. Do I even need to do that? Is this loop even necessary? I think so. I mean, what happens if I remove it? Or actually, I don't want to remove it because... No, let me think about this. We start with this loop, room equals 1, print list. I got this print statement twice, so it does execute a second time. The problem is, I think, with the iteration. Maybe if I don't remove, and I don't have the while loop, this could work just fine. No. Unexpected indent. Okay, this is syntax related. Okay, I need the solution though. There you go. Okay. If it works, I'm going to explain it in a second. But the idea is remove this. Shift this to the left. Get rid of this statement. Was this everything I changed? Yeah, okay, now it works. Okay, so the difference is that the problem was that I was iterating over the list while removing elements from the list. So maybe I can show this here in a Python 3 shell. If I have my list with the values 1, 2, 3, 4, 5, and then I say for element in my list. Let me just zoom in a little bit. For element in my list. Print element and my list remove element. Then I get this 1, 3, 5 and not 1, 2, 3, 4, 5, because the problem is I say for element, it iterates over the list, but while it's iterating over the list, I'm removing elements, which leads to problems. All right, so that is now a solution that works. Let me see if I can optimize it in any quick way here, because I don't want to spend too much time on this. I think I want to do another one. So I think I'm going to just quickly see if I find some quick optimization here. We're basically saying we have an empty solution. We have an empty solution dictionary. Now we need the dictionary to keep track of this comparison. We need to also iterate over all of them to make sure. I mean, we probably don't have to, but I don't want to do some calculations now to figure out if I fit in between some specific section of the dictionary. I mean, we could probably, instead of keeping track of all the individual customers, we could probably define like a range, or we could define ranges that are occupied. But I think I'm going to just leave it like this, and we're going to see if there is some much more intelligent solution by someone else. So I'm going to attempt and hope that this doesn't take too long. Come on. Holy shit. What is this? Random tests. Testing number of customers 787, rooms needed 414. Number of allocated rooms is larger than necessary. Okay, come on. Why is that? Okay, I think we're not going to do another one. I have to do this one and get it right. Using more rooms than necessary means that I'm rejecting without having to reject. And I'm only rejecting actually here. If I'm only rejecting in this case, then this case is too strict, which means that there should be cases in which I should allow something that I'm not allowing here. Let me just get rid of all the stuff here. What could be such a case? It seems to happen only with large numbers. So why is that the case? Customer is, let's say, 1 in 90. C is, I mean, what's the condition now? Customer 1 has to be less than C0. So it has to be less than whatever this is, 91, for example. Or customer 0 has to be larger than, so it would be something like this, 91 and 200, and C would be then 1 and 90. These are the only two cases I accept. Are there other cases? Could there be a case where neither of the two is the case? So where C0 is greater, no, C0 is less than customer 1. So let's say customer is just 10 and 20. Now C0 is less than 20. Let's say 5. And customer 0 now it doesn't make sense, does it? I'm not sure. I mean, isn't this by definition? I mean, maybe let's consider multiple instances. Let's say I have a, I think, let's say I have the following list already. I have 1, 5, then I have 6, 10, then I have 11, 50, then I have 55, 100. Something like this. And then I want to add a new element. let's say I want to add 52, 54. What would happen? I would go and say, okay, looking at 1, 5 and 52, 54, I mean, this should work, right? Because customer 1, 5 is less than this, so it works. Or does it? Yeah, I mean, we don't do anything, so we jump to the next one. 610 works. 1150 works, and then I get to 55, 100, and it also works. So when do I reject a possible solution? I'm not sure I understand. Because when I do test, it passes all the tests. But when I do attempt, it somehow doesn't work with the random examples. Non-overlapping tests. Random all overlapping tests. Random tests. So where we do have some overlaps. This is more difficult than I thought for a 6Q challenge. Or maybe I'm just stupid, but we have a solution dictionary with all the rooms. I would like to have such an example. I would like to see the example that doesn't work. But I don't want to print everything now. So what is the... I mean, these are just the sample tests. I would like to see the random tests. Can I see the input or anything? Number of customers, rooms needed. There's probably some intelligent algorithmic solution to this that is super simple. I don't understand why I use more rooms. Because in order to use more rooms than necessary, I have to reject rooms that I wouldn't have to reject. So in order to use more rooms than necessary, I have to say, okay, you don't fit into this room, even though you would fit into this room. Because the only reason why I add a new room... Is that true? Am I maybe increasing the room number too early? That could be another problem. No, I think I get into this if there is an overlap. Then I increase the room by 1. I break out of the loop. Since I'm breaking out, I'm not getting into this. Boom, repeat. If room in... Yeah. I mean, I don't know. The problem is I don't have an example. I cannot even troubleshoot this because I don't know where this would fail. Because all the examples that I have here, they work. So it works for at least small numbers, I guess. So what could happen when we scale it up? What would happen when I have... Oh, I have an idea. Or I'm not sure if I have an idea, but let's say I have something like 50... No, actually, yeah, let's say this is 53. And let's say I have here something like 54, 54. Would this cause some issues? Customer 1 is less than this. This is not true. But customer 0 is larger than this, so it shouldn't reject it. What if I try to add something like this? 53. It should work. How would I not get the optimal number of rooms here? Because the only thing I'm doing is I'm looking at a solution. I'm looking at a candidate, and I'm saying, in a given room, we start with room 1. I want to see, do you fit into this room? For this, I see, does this room already exist? If it exists, I want to see, what are all the customers in the room? If there's a conflict, we go to the next room. We break. That is as simple as it gets. So why would this not work? The condition for something to be compatible is that they don't overlap. And overlap means that one has to start before the other one ends. One has to start. So or to be compatible, one has to start after the other one ends, or the other one has to start before the one ends. What are examples of compatibility? 1 and 2 is compatible or let's go with 2 and 3 is compatible with 1, 1. 2 and 3 is compatible with 4, 4. 2 and 3 is also compatible with anything like 4 and 10. 2 and 3 is also compatible with anything like, yeah, if we go below, let's say we can do something like 0 and 1 as well. Is there anything, any other chance, any other possibility to be compatible with 2, 3? Because the same day is not allowed as far as I saw. You're not allowed to have the same day. So if it's on the same day, it's not allowed. And does this condition reject any of these? Let's say this is customer, this is C. Customer 1 is below C1, no, okay, C0, okay. But this is below this. Yeah, so either this has to be below this, or this has to be below this. This has to be below this, or this has to be below this. This has to be below this, or this has to be below this, and it's always the case. So I guess that this is not the problem. If that is not the problem must be something else. The problem must be that I'm increasing the room too early, too often, something like this. Does it say somewhere how many more rooms I use? Is this some slight difference, or is this a huge difference? Okay, it doesn't really tell me how many rooms I use. Maybe I use just one more room. It did work here though. So, oh, here as well. So it does work occasionally, but oftentimes it doesn't. Which confuses me even more. When I reject, I increase the room by 1. And I break. And I repeat the process. And now I have room 2. Okay, guys. I don't know. I don't want to give up on this. I think instead of just giving up and looking at the solution, I'm gonna break one of the rules. I'm gonna say that I'm gonna use GPT to see if I can get some answer from it. So let me just open this on my second screen here. I'm gonna see if I can get some magical solution. I have this code to solve the problem of placing customers in hotel rooms without overlap. It does work most of the time, but for some reason I have an issue with large randomized instances. I use more rooms than necessary. Why could that be? I mean, this is just... I mean, this is just efficiency stuff, right? So this doesn't really produce problems. Now let me just see, I'm just going to copy paste this to see if that solves the problem, so then we can analyze it, but oftentimes it doesn't, so I don't want to spend time looking at code that doesn't solve the problem. Let's just copy paste this. Actually, let's do it. Come on. Let's just do it like this. And we're going to replace list by customers. First of all, does this still work? It does work here. Now when I attempt no, okay, it produces the same problem. Okay. So let's just return to what it was before. It's kind of embarrassing, to be honest. I'm not sure if I'm really that stupid right now or if it's not that easy. Let me just rephrase this. Now I don't see what I'm typing. I am not talking about inefficiencies. Did I spell this correctly? Inefficiencies. I am talking about not using the optimal number of rooms. Oh, this makes sense. Okay. This is true. Okay. Oh, now I get it. I'm using a greedy approach. I'm just checking, does it fit into a room? I'm not checking what's the optimal order. Okay. Okay, so this is, okay, I'm not going to do this now, but I understand now what the problem is. The problem is not that my check is wrong per se, it's that my algorithm is a greedy algorithm trying to just see, okay, does it fit into this room? No. Does it fit into this room? No. Does it fit into this room? Yes. So put it in there instead of asking, does it fit into any other room? And what's overall the best solution? So my approach works per se, so it finds a solution. And probably it's not the worst solution. As you saw, oftentimes it finds the optimal solution, but this is the stuff that I usually show you in these algorithmic problems. Yeah, I'm just not going for the optimal algorithm. What I would be interested in is this an NP-complete problem? Okay, it's an I mean, if he's correct, I'm not sure if ChatGPT is correct right now, but if this is an NP-complete problem, you basically have to brute force it for the optimal solution. Or not. Let me just try again to ask him if it's NP complete. Let me just open up a new instance. Oh. What kind of algorithmic problem is this? Interval scheduling problem. Interval scheduling problem, NP part. NP complete when some groups contain 3 or more intervals. Okay, so this shouldn't be NP complete actually. Okay, but I think I can say that I somewhat failed this. I mean, I got a solution that works. It's not the optimal one, so let's just skip this and see. Now, actually, I wanted to see the solution. Unlock solutions. There you go. So yeah, there you go. This is unfiltered, unedited. I failed this. And this would have been a nice, easy solution. What is res and depth length customers? Result, I guess. For IAD in sorted enumerate customers, sorting them by their end date. So by their departure date. Okay, so it just creates. Yeah, I mean this is just a different order. This is also done here with a heap. It's just a completely different algorithm. I went for the greedy solution where I just put everything together, and oftentimes this results in the so I basically fit every single customer into the first possible room, which oftentimes leads to a good solution, but not always. And yeah, I mean, it's actually, I think this is quite hard for a 6Q challenge. Now, maybe I'm just too incompetent to solve it, but also the solutions here, I think you either know about this, you know the algorithmic problem, the interval scheduling problem, and you apply the solution to it. In this case, if you just know it, or if you've thought about this already, then it's quite easy. But if you didn't do that, then coming up with a solution yourself is a little bit hard for 6Q, I guess. So yeah, I can say that I failed that. I'm not going to do another one, so I think that's it for today. Just 2 challenges. I think it was still interesting. We had to apply for else. I think the solution does work. It comes up with a valid solution. It doesn't come up with the optimal solution. So we can say we solved it to some degree, but we didn't solve the kata itself. Yeah. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.